This 2022 paper 2 question 3, we have circle stuff, and the equation is kind of like this. So we're going to use this stuff from the formula and tables book, where we have x squared plus y squared, and then we have it kind of all expanded out. All the brackets are expanded out, and we need to figure out what k is. So the first thing is to do anything, we need to figure out what g, f, and c are in this equation. So let's do that. So we're going to rewrite our original equation and just write it in the form here so that we can kind of mix and match. So x squared plus y squared. And instead of writing minus 2x, I'm going to write plus 2 times minus 1x. And you'll see why I'm doing that now in a second. Plus 2 times 4y plus k equals 0. Because now you can compare. So we have 2 times minus 1x, and here we have 2 times gx, so it means that g is equal to minus 1, and then we have 2 fy, so our f is 4, and then our c is just equal to k. We need to figure out what k is, and they tell us about the radius. We're not told about the center, so we'll use the radius. So we know that the radius will be equal to 5 root 3, and that's equal to the square root of g squared plus f squared minus c. So now we can just sub in, so 5 root 3 will be equal to the square root of minus 1 squared plus 4 squared minus k. And now we have an equation that we can solve for k. So we can square both sides, and we'll get 25 multiplied by 3 on the left side. Or you can just square it in your calculator, and you get the square root. The square root's gone. 1 squared is just 1. 4 squared is 17. So we get 17 minus k. So then we get 75 is equal to 17 minus k. And then you can just solve for k. And you can bring the k to the other side to get k equals 17 minus 75, which is just equal to minus 58. Then we're told about a circle and its tangent. What's the slope of the tangent? So what might help is if you draw the circle, so it doesn't have to be perfect, but we are going to say the center is going to be 5 for the x coordinate. So the center is 5, and then we're going to have minus 2 for the y coordinate, because this is minus 2, and then the tangent's at the point 9 minus 4. So it's going to be down here. So we're going to have 9 minus 4. So you kind of use implicit differentiation, but I know that a lot of people don't cover that. So the way that, more standard way that most people would do probably, is you can find the slope of the radius, and then the slope of the tangent is perpendicular to that. That's not a very well drawn tangent, but you get the point. So we can find the slope of the radius because we know the 2 points, and then find the perpendicular slope. So the slope will be equal to y2 minus y1, which is the rise, over x2 minus x1, which is the run. So this can be our x1, y1. Here we can have x2, y2, and then we can do y2 minus y1, so minus 4 minus 2 is going to be plus 2, divided by x2, which is 9, minus x1, which is 5, so we'll end up getting minus 2 over 4, which is equal to minus a half, and that should make sense, because we drew our diagram correctly. We can see that it is indeed a negative slope, so then the perpendicular slope to that will be equal to just, well, it'll be positive 2 over 1, because we take the reciprocal and multiply by minus 1. And you can see here, indeed, then we get rid of that, because 2 over 1 is just the same as 2. So the perpendicular slope is 2, and that makes sense. It should be sloping upwards, as you can see from the diagram. So, yeah. So we have this interesting question where you have two circles. They both contain this point, and they're tangent to the axes. We need to find the equation of both the circles. So if you kind of think about these circles, think about their centers, right? And if you go straight up from there and go straight to the left, well, they're going to be radii of the circle, right? So we can call this r. So these are both radii, r and r. So that might actually show you the coordinates of the center. So for example, for that big circle, the coordinates are going to be of the center. Well, we have r units to the right, so it's going to be r x's, and then we go r units down, so it'll be minus r. So that's the center. And it's the same for the smaller circle as well, right? If you draw in the center, this is the radius and this is the radius. Because we don't know what r is, we'll probably end up getting two values because we have squarings and stuff in the equation of a circle. But then if that is the case, there's obviously infinitely many circles that could satisfy that. Like you could have a center over here, you could have the radius, and you could have the radius, and you could have a big circle here. So we need to make sure that we're only going to get two possible answers, as we have here. So we have to make sure we use the other piece of information, which is that it goes through this point, and that limits us down to only two possible circles. So we can just write the equation of this circle. So we can write x minus the x coordinate of the center, which is r, plus, and that's whole thing squared, y minus, and then the y coordinate's minus r, so we're going to end up having plus r squared will be equal to r squared. And again, the problem is there's infinitely many answers here for what r could be, depending on what x and y are. But once we say that we go through the point 1 minus 8, so that's a valid x and y coordinate, so we can sub that into here. So we'll end up getting 1 minus r, the whole thing squared, plus y, and then the y coordinate is going to be, or sorry, the y coordinate is minus 8, so we're going to have minus 8 plus r, the whole thing squared, equals r squared. Then you can see this limits our choice down to there's only 2 values of r that are going to work here, and that makes sense because we need two circles from our question. So we'll have 1 minus 2r plus r squared when we multiply that out, and then we're going to have plus, and then we're going to have 64 minus 16r plus r squared, and it's going to be equal to r squared. So these r squareds cancel out, which is nice. Then we'll get r squared, and then we have minus 18r, and we'll have plus 65, and that'll be equal to 0. 65 nicely factors into 13 multiplied by 5, and then obviously minus 13 minus 5 gives us r. So we can factor this as r minus 15. Sorry, I meant r minus 13 multiplied by r minus 5. That'll be equal to 0. You can multiply that out and check that it does indeed work. And then you get that r is equal to 13 or r is equal to 5. And it makes sense that they're both positive because that means that these signing conventions work up here. If these were negative, that would kind of be a bad sign. Because then this x coordinate would be negative, so it would be over here somewhere. So we probably did something wrong, but we know that we got it right here. So yep. So now to write the equations of these circles, we know what the radius is, and we know that they both look like this here. And that's just because we know what the center is r minus r. So I actually might just bring this down, and we'll use this. So for the small circle, we're going to have x, and then we're going to have the x coordinate of the center is r, so we'll have x minus r. And in this case, r is going to be 5 for the smaller circle. So we can just have x minus 5 the whole thing squared, plus, and then we'll have y plus 5 the whole thing squared. Again, that's because it's y minus k, but the y coordinate here is negative, so it'll be minus and a minus makes it positive. And that'll be equal to, the radius is 5, so 5 squared, it'll be 25. So that's the small circle. In terms of the big circle, we just have the same thing, except we're doing 13. So we'll have x minus 13 squared plus y plus 13 squared will be equal to, and the 13 squared is 169. So yeah, there's the two equations.